Vanakkam and happy morning to one and all present here. Mondays are great to greet a new week full of optimism. We wish this great Monday morning may bring hope and courage forever. It's so delightful to see you all on this webinar. As our country grappling with corona pandemic, the college premises remain closed. Yet, webinars of this kind can bring education right to your home. Pandemic is not a barrier for achievements and accomplishments of our university. Yes, we are a proud participant of Dr. APJ Abdul Kalam Space Research Payload Cube Challenge 2021. A Guinness record event involved the launch of 100 femto satellites in a high altitude balloon on 7th February from the birthplace of Kalam Sir, Rameshwaram, in which a team of students from our university designed and developed femto satellites, of which 10 young aspirants are from first year, a historic pride for our campus. Though students are randomly selected for this great mission, they volunteer themselves as a powerful team. Yes, and we could proudly say, இது தானா சேர்ந்த கூட்டம். ஒருவனுக்குள் இருக்கும் திறமையை விட அவனுள் உள்ள ஆர்வம் மிகச் சிறந்தது அல்லவா? Yes, certainly yes. Interest can do better than the experience. இப்படி ஆர்வத்துடன் தான் கற்ற கல்வியை கொடுக்கும் போதும் மகிழ்ச்சி, அதை மற்றவர் பெறும்போதும் மகிழ்ச்சிதான். And it's a great day that we have been planning and waiting for. As this wisdom crowd is holding a session today to share their knowledge pack on femto satellites, let's all drench and quench our knowledge thirst. On this special occasion, it's my privilege and pleasure to welcome our legitimate leader who never dreamt about success but worked for it, who is our Dean Ma'am, Dr. N.S. Subhashri. A cordial welcome to deliver a keynote address. Ma'am, please.
Thank you, Dr. Lata. Am I audible?
Yeah, yes, ma'am.
Thank you. So, good morning, my dear young aspirants. So, before starting my address, I would like to thank our honorable and beloved President Sir for making us believe what we are. Yes, whether it is a small program or a great mission like this, he has never said no. So we are a part of a proud moment now. On this August occasion, I would like to extend my welcome to our VC Madam, Provost Sir, Rector Sir, Registrar Sir, Additional Registrar Sir, all joint registrars of all campuses, directors, deans, HODs, teaching and non-teaching staff, my technical support staff, and my dear students. Sometimes you will never know the value of a moment until it becomes a memory. Yes, today, this program is a memory sharing event, a program by the students for the students. So, you are going to witness the students who were part of Dr.M.G. R.FEMTO Cube Satellite Challenge, and they are going to reinforce the knowledge sharing. I would just like to rewind and go back to January 2021, where this all started. One fine day I was called and I was told there is some thing that is going to happen. There is a proud record is going to be happening, and our university is going to be a partner in it. So I was asked to select 10 good students from first year ENT alone and give it to them. During January 2021, our institution announced their proud participation of Dr. APJ Abdul Kalam Space Research Payload Cube Challenge 2021 by launching 3 Dr. M.G. R.FEMTO satellite on 7th February 2021 from Rameshwaram. This great mission soldiered on launching 100 femto satellites in a high altitude scientific balloon, which included 4 world records. to ignite the young minds in the work on STEM knowledge, that is science, technology, engineering, and mathematics knowledge and skill, we were given an uphill task of selecting students for this mission. As I told you, we have to select 10 students from first year alone. And as you were all new entrants, and we had only online classes, no offline. So, with great discussions with our staff and all the students after subsequent classes, we were all discussing, and finally, we succeeded in bringing 10 students. Yes, as Dr. Lata told, at that time we didn't know what are the hidden talents, but now we have become a memory. And yes, they are here before you to share their memories and proud moment of this historic participation. My dear students, this program is purely a motivational, inspirational one. These 10 students are now standing before you to share their memory and how their journey, their journey in this proud moment. And this should be really a motivational factor for all the other students to take part in many such challenges to come. I would like to end up. You are braver than you believe, stronger than you seem, and smarter than you think. If opportunity doesn't knock, build a door. My dear students, the world is waiting for you. Make yourself ready to conquer it. Thank you. And I am also proud to be a part of this very great achievement. Thank you.
Thank you so much, ma'am, for narrating the historic event that held at Rameshwaram and the preparations that we made at our campus. And I too feel that these students are the representatives of entire first year. Thank you so much, ma'am. The energy introduces you before you speak. And here is a person whose energy is contagious. Save energy, feel energetic is his motto. A macho contributor towards energy conservation. Who is our Dean, EPA, Dr. L. Ramesh, sir, the project head of this great mission. We invite sir to address the august presence. Sir, please.
Thank you, ma'am. Thank you. Very warm, and it was very nice and good morning. Very happy morning to all the first year students plus other participants, those who are watching YouTube. It was very great initiative by the first year dean and the team to the taking back the sharing of the good things to other people, other students. That is always very important. The reason behind what madam rightly pointed out, when we started the initiative, when I had a discussion with our APJ Sheikh Dawood sir, grand nephew of APJ Abdul Kalam sir. So when we had sir, he told that Ramesh, why can't your college participate? Then we had a discussion. After that, we had discussion with the president. Finally, come out with the president want to have 3 team. So we want to have 3 teams. Then president decided yes, one we can able to give to first year alone, and the remaining 2, one is for H&S and another one is for other engineering, that is second year, third year, final year, like that. So this is actually the team which we planned, and so when that name, now that this FEMTO name is very familiar and very passionate for all. Before that, there is no one. We also not known very much aware of the importance of that assembly of satellite. So before going to that, after going to that, like that, we have a history. So the students also felt very hard. They feel that very tough to go for launching of satellite, very tough to go for assembling of satellite. But it made this workshop and this launch of the program made a very good confident level for the students. Not only our students, around 1,000 students participated in the great mission. In this 1,000 students, the confidence level got very much increased. So that is the initiative, because what our Abdul Kalam sir dream Sir oda kanavu. So that dream has to come true through the students like you, because when Sir Abdul Kalam sir இருக்கும்போது அவரோட sir வந்து done a seed அப்படின்னு சொல்லுவாங்க. So sir put seed on the whole country to development for the nation. That is what we made it on the on February 7th in Rameshwaram. Our 3 MGR femto satellite with the another 97 satellites launched, and after 2-3 days we got a result also related to that. So that is what they are preparing for, that to publish for their paper and publish for a report, and that process is going. So this is a success story. Yes, during the success story, yes, there is a lot of friendship in between the other college students happen. Maybe our MGR students connected with other college students, MGR students connected with school students, and there is a networking between seniors and juniors, networking between H&S and engineering. So ultimately it will be a very fruitful platform, and it is given more confident, and I am very happy one of our students now working in that organization also. So thank you to that student, because based on when I was the witness on that day, I feel that MGR is launching. The reason is where it is a control room, MGR students are there. The major part in the control room, our MGR students, particularly in the MGR students, first year students are there. That is what the major thing. That is the reason today we had this program. So when we go through that point there, the first year students are there. When we have another, that is where the launching area, our students are there. So when on that day, when I witness in the passion that MGR is launching a satellite like that. Even though we are part of that, out of 100, 3 satellite we are part of that, but we felt like that because of the involvement of the students. The reason is 5 students from our campus went to Rameshwaram around 10 days back. They worked there for 10 days, and the remaining students there for 2-3 days, and had a very good experience. And maybe tomorrow, after a couple of years, we can able to see the students in the ISRO or DRDO. So that kind of result we got, and maybe students also now continue and they are working. Because of the COVID, we can't able to take it to the next level. So actually we thought we need to take it to the next level to form a satellite club. And so once the college will get back, we are planning to make the same team and continue to plan a satellite club and get new students also, and take it to the next level. So this is one part, launching the satellite in the Rameshwaram. Next, our team has to go abroad, out of the country, to launch the satellite, and our satellite to launch in our ISRO. So like this, there is a lot of missions are there. So we all have to work together. And another thing, so the students, those who are not participated, don't feel that you not participated, because there is a opportunity will come for only limited students. We have a book for that. So all these students are having the book, and so maybe I have some spare book also. I will give it to the first year dean ma'am. So ma'am will place that book in the library also. The complete thing, assembling of satellites are available in that book. So any student, those who missed that also, they can go through the book and come out with your plan. So this is what. So thank you all. Thank you all the students who participated, and thank you all the students who are watching the program also. Thank you, ma'am.
Thank you. Thank you so much, sir, for reminding us the launching pad where Anginkenadapadi, ella edathalayum we could notice our students. And even the dais also, we request MGR students to come over here. We request MGR students to go over there. So that type of announcement is hearing edge in my ears. Thank you. Thank you so much, sir. And now I do feel that this type of social events will develop the social skills and the emotional intelligence of students too. Thank you. Thank you so much for the chance. Thank you, sir. And now here comes a visual treat to your eyes, an insight into a massive mission. And we request Ms. Maheshwari ma'am to play the same. Yeah, that was very nice. First year, an arena to voice your ideas, get involved, and make a change. Here you go for the first time. First year virtual dais is festooned with student speakers. Now I would like to invite Sherin to take up the dais.
Thank you, ma'am. Am I audible?
Yeah, proceed.
Okay. Hello, guys. A very good morning to all. I'm Sharon Grace Levina from MGR University IT department. I will be explaining about the mission summary of what we did back there in Rameshwaram. There are many different kinds of satellite and also varies in different sizes. In that, the least one is femto satellite. It is a satellite with a low mass and small size, usually 100 500 kg in a minimum range, which weighs below 100 gram, that is around 3.5 ounce. To be approximate, 1 tablespoon is equal to 2 ounces. So look for yourself 2.5 tablespoons. That much weightless it will be. A femto satellite is also called a small satellite, miniaturized satellite, or small satellite. 100 tiny femto satellites designed and developed by 1,000 students from across the country will be launched into space on Sunday from Tamil Nadu's Rameshwaram, the birthplace of former President APJ Abdul Kalam. Of the 100 satellites, 38 are from Maharashtra, which includes a satellite from Mumbai based Children's Academy. These satellites are launched under a joint project by APJ Abdul Kalam International Foundation and also Chennai based Space Zone India, which was supervised by Anand Meghalayam Sir and another organization called Martin. The satellites are made up of composite material and also cube like structure. We also know that cube means all sides of the same length, so this femto was 4 cube centimeter. These satellites, when launched in large numbers, are useful for gathering scientific data as well as for radio delay. They are also used for training purposes. The satellites are also equipped with sensors to study areas like ozone, cosmic rays, carbon dioxide, and humidity. But we worked on two different types of sensors and fibers. So 50 satellites are loaded with sensors and 50 satellites are loaded with fibers. So totally, we launched 100 satellites. So for launching this satellite, it doesn't require a specific launching vehicle because this doesn't reach outer space. So it was launched by a parachute. To be precise, it is called a prop balloon filled with helium. We launched these on February 7th at 11 a.m. Rameshwaram, and we had a GPS track inside that balloon to retrieve those satellites to get the readings. So we can retrieve it in 3 days. Maximum, it can take a week. But unfortunately, our GPS signal has been lost. So we put on a lot of effort in search of it. And we finally retrieved it after 2 weeks in Kovilpatti Kolavur Gramam. In that, two satellites failed to perform its functions. But we retrieved 98 satellites in a perfect working conditions and took all the informations we required. So what I have till now explained, what we did back there in Rameshwaram. So fellow team members are also present here. So they will be giving a brief explanation and what is FEMTO, what are the things used in productions of FEMTO, and many other things. So fellow mate Jonathan will be taking over the lead from here. Thank you.
Thank you, Sharon. That was a good speech. Ma'am, I'm audible, ma'am. Hello, am I audible?
Yes, yes, proceed.
Okay. Hi, I'm Jonathan from MGI University Mechanical Department. Commonly, a question arises from three W's: what, why, and when. So, speaking about the femto, what is this femto? Why do we need it? What is the purpose of creating such a small satellite? It is kind of like a tiny cube structure where we can see everything around us has evolved into a small, compact, smart, etc. So, I'll say femto is the smartest way in satellite production. So its size has been greatly reduced to reduce the large economic cost of launching vehicles and satellite construction. It weighs around 100 to 500 grams on an average. That reminds me of when we worked in ground station, we used to wear a ESD gloves which were specially made for handling the satellite. We must have a delicate touch when we handle it. Do you guys know how much time or days it will take to construct an average satellite? It will be around 1 or 2 years in minimum, 3 to 4 years in maximum. But it took around 2 to 3 months to create this femto. Time consumption, financial restraint, overall, it has a great advantage. Commonly, you guys know that satellite means outer space, galaxies, blah blah blah. But don't think like that. This femto also doesn't reaches outer space. It'll be reaching the height or within a suborbital.
Jonathan,
Yes, ma'am.
Jonathan, sorry to interrupt. Can we have
Yes.
PowerPoint?
Actually, Vishnu will be doing the
Yeah,
PowerPoint
yeah.
now.
Please hold on for a minute.
Yes, ma'am. Actually, just move on to the other page, ma'am. The other page. Yeah, okay, fine. Commonly, SAT is used for communication, study of planets, planet geography, etc. But this one is quite different. This SAT is used for training and also study purpose of atmospheric gases, agricultural resources, depending upon the what type of payload you're using. The femto satellite contains many different types of payload. So now another question rises: what is this payload? Payload is an object or an entity which is carried by an aircraft or a launch vehicle. Sometimes payload also refers to a carrying capacity of an aircraft or launch vehicle, usually measured in terms of weight. I don't think many have got a catchy idea of this scientific explanation. Okay, I'll give a quite example for it. If a bomb shell has 10 bombs in it and those bombs are called payloads. So we're going to see about only two type of payload sensors and fibers. What we did is total 100 satellite, 50 sensors and 50 fibers and launching of this sat by parachute control system. Everyone might be aware of what is a motherboard which connects to all part of the main system to keep everything under its control. You see, this femtosat is not just a box made up of composite material. It also consists of boards which are used for main function of the satellites called 80 mega and also micro SD card. So Venkat Sai Yadav has mastered this topic. He'll be taking forward from here. Venkat, you can go ahead.
Yeah. Am I audible? I hope I'm audible. So as previously
Yes,
Jonathan
yes.
explained what is femtosatellite is, why we need it, and what are its uses. And I will explain the core of the femtosatellite payload, particular type of payload which consists of sensors, the main board which are there in this mission. So myself, Venkat Yadav, are BTech first year in ISDF department, here to explain why we need these kind of boards into this mission. At first, 80 mega controller board. Move on to the next slide, please. Yeah, thank you. As we're able to see, the first board is the 80 mega controller board, which acts, it's a motherboard. A motherboard is there to function, to make sure that every function is doing it correctly. So inside the motherboard, we have the black color, a square-like structure. It's the 80 mega controller. So it's a processor which used to give the instructions to the board. Why we need this? So as a human, we all do instruction. We all do work by the instruction given by our brain. So the 80 mega controller board acts like a brain to give instructions to the other parts of the satellite. What is this? Why it's need actually? So it is an 8-bit processor which consists of 28 pins. Why we need an 8-bit processor? To give instructions effectively. So these instructions are being loaded when the program is uploaded. The 80 mega controller board has a digital input and analog inputs so that the values will be noted perfectly. Moving to the next board, it is an payload integration board. It is also said to be a micro SD card shield. Why we use this? So I'm going to explain it very detailedly, but in a shorter way. When we take a photo in our camera, where it will be storing all those data, it will be stored to an SD card. So likewise, we have made it as simple as that to know people how effective it will be. All the data which have been collected from the sensors will be stored in the SD card. So later on, during the retrieve time, we will able to get those data back for the reference purpose. So this board carries all those sensors will be integrated into this board. So that's what The 80 microcontroller acts like a brain, and the payload integration board acts like a body. Over to next slide, please. Why we actually need an 80 microcontroller board? So, first foremost thing, we must think of the price, because everyone must knowing it what it is actually. It is inexpensive. Everyone could able to learn at any cross of platform. So we are using an Arduino IDE software to do the programming in this work. It will be very efficient so that every people can able to access it. It is very simple and clear programming language so that a small children can able to learn even with the basic knowledge of programming. It is an open source software, also reliable for every person who able to access it. The hardware which have been used in the circuit are very simplest circuit so that every people could able to understand what's there from the basic to the higher part. So next slide, please. Why we are using this 80 mega 328p microcontroller IC? Why can't we go for another IC? So what is the real need of it? I already mentioned it is a 28-pin processor which consists of 8 bit. So all the programming will be stored in this. It will be getting all these instructions and giving the instructions to the other part. So as I previously said, the 80 microcontroller board loaded with the program will be given the instructions to the payload integration board, and the payload integration board is connected to the sensor, will get the data and store it to the SD card. So this pin we have used a flagship pin for the processing. So mostly people ask, why can't we go for another pin? Why can't we go for another ICs or another pins? So it is very easy to understand. Mostly people can able to do it with the basic knowledge of programming. That's why we are using a 80 mega 328p IC over here. Next slide. Yeah, this is the final output what we get. We have designed the PCB in such a way that all the parts are compact and very user effective. So first the 80 mega controller will be connected to the payload integration board, and the bottom you could able to see there is a battery like thing. It is the real time clock. It's a sensor which has been connected to the payload. So the primary two boards are being explained by myself. So have you ever think what the thing will happen inside the box? The cube is a 4x4x4 structure. It's a carbon monopolymer, which is with material is used to build that cube. Inside that there will be a hose to give the air over the function to for the sensors to give the accurate values. Motherboard is connected to the payload integration board by clipping it, and the sensors will be connected through soldering. As such simple the circuit is. So will the body work without the hands and legs? Have you ever wondered how it's happening? The most important thing, the sensor plays a vital role in this part. So my friend Tarun will explain detailedly why we need sensors, what are its functioning, and actually how it's going to be work when we connect it to the actual boards. Thank you guys.
Am I audible, ma'am?
Yeah, you're audible.
Okay, ma'am. Thank you, Venkat. I'll take it from here. Hello, everybody. I'm Tarun Kumar, BTech Computer Science Department, first year. We just heard our friend explain about microcontrollers. Let's keep it simple. A microcontroller is the brain of the whole satellite. It knows what to do, when to do, and how to do, and it is the one which does all the arithmetic and logical processing within itself. But it can't do anything alone. It needs some attributes like hands and legs to do the job. So here comes the play of the sensor. What is a sensor? A sensor is a device that detects the change in the environment and responds to it in some output on the other system. A sensor is a device which converts a physical phenomenon into a measurable analog voltage, which is later converted into a human readable context or transmitted into reading and further processing. Let's see about some of the sensors which have been used in our satellite. First, BMP 180. Next slide, please. Yeah. BMP-180 is a barometric pressure sensor which is designed to predict the weather, altitude, and measure the vertical velocity. One provides the information in a digital output. It is perfect for weather stations, remote control vehicles, water balloons, and a lot of other projects, which is extremely sensitive sensor too. It can detect the altitude for just a few inches. The BMP-180 sensor comes with a module which has 5 pins: a volt, a 3.3 volt input, a serial clock pin, a serial data pin, and a 3.3 volt and a 5 volt input and ground. A 3.3 volt input can be used instead of 5 volt if we don't have a 5 volt in power supply. Some of the key features of this sensor is it can measure the pressure ranging from 300 to 1100 HPA, which is hectopascal scales, the SI unit of pressure. It consumes less power, such as 3 microamps. The pressure conversion time is less than 5 milliseconds, and it's super small, so it's portable. Portable. Next, next slide, please. Okay, next slide. DHT11. DHT11 is the next sensor. It is the digital and humidity sensor, which is used as a temperature sensor for most of the purpose. The sensor comes with a dedicated NTC or negative temperature constant to measure the temperature and give an 8-bit microcontroller for an output values for temperature and humidity as a serial data. It is a capacitive humidity sensor and a thermistor to measure surrounding air and spits out the data in a digital signal to one data pin or an analog, non-need to analog pin, a data pin in the microcontroller. It's fairly simple, but it requires careful timing to grab the data. DHT11 has 3 pins, a VCC, a ground, and a data input and output for both temperature and humidity. Simple. The fourth pin is actually not used for anything. Some of the key specifications of this sensor are it has the temperature ranging, it can measure the temperature ranging from 0 degrees Celsius to 50 degrees Celsius, and the humidity ranging from 20 degree to 90 degree percentage, and it is mostly accurate. Next slide. IR sensor. We have seen a weird white color LED, a transparent LED in a TV remote, right? Yeah, that is the infrared light LED, which has been used as an infrared sensor. We have seen a lot of LEDs in TV remotes and a lot of other products. The IR sensor emits an infrared light in order to sense some objects of the surroundings. An IR sensor can measure the heat of an object as well as detect the motion. It usually in infrared spectrum. These type of radiations are invisible to our eyes, but the infrared spectrum can detect these radiations. IR sensor have two parts, a light emitting diode, an IR LED, and a receiver. When the object comes closer to the sensor, the infrared light from the LED hits the object and bounces back on the path and is detected by the receiver. An IR sensor acts as a proximity sensor too. Some of the key specifications are it only works at like 3.3 volts and its range up to 200 millimeter or to 20 centimeter. It has an adjustable sensing range. Next slide, please. UV sensor. Okay. Just like the name says, we can easily identify it. Yeah, it's an ultraviolet sensor. It sends the ultraviolet radiations from the sun or the surroundings. An UV sensor is used for detecting the intensity of an incident ultraviolet radiation, which lies in the ultraviolet range. These wavelengths are shorter than the light, but longer than the X-rays. UV sensors are widely used in many different applications, including but not limited to automobiles, pharmaceuticals, and robotics. It can be used to detect the intensity of the incident ultraviolet radiations, like the UV radiation from the sun. Next slide, please. GPS. We know what is a GPS is, right? Because we have mobile phones, laptops, and even some of the smartwatches we have has GPS in it. It's used to give the precise location of the device or the person who's wearing the device. A GPS is a satellite navigation system which is about 20,000 kilometers away from the Earth. It can provide us with the information of location and time. It can work 24 hours a day under any conditions. A complete GPS system requires at least 24 satellites, as the technology is developed with more than 33 satellites to work together in a system of GPS. It simply checks the location on the Earth and provides the coordinates, which is the longitude and latitude of the Earth. The GPS receiver on our phone or laptop or smartwatches, which listens to these signals received by the receiver. Once the receiver calculates the distance between from more 4 or 5 satellites, the GPS sensor can figure out a way, and it can detect the person's location and time information. It's compact, so it is super powerful, and it has a energy efficient chip, so it can be used in any of the devices, and which is more important for this femto satellite. Some of the key specifications are, it is a standalone receiver, so it doesn't need any extra power. It has a EEPROM, is a electrically erasable programmable read-only memory, which is used to store those location data, which is highly important, and it has a 3.3 volt input. Okay, we have seen some of the sensor, how it works and what it does. Now comes the crucial part of the satellite build production, which is programming. Here's a fellow teammate Vishnu to say more about programming. Vishnu.
Am I audible, ma'am? Okay. Thank you, Tarun. Till now, my friends explained about boards and sensor of the satellite. But wait, we can't launch a satellite without doing programming. Yeah. Myself, Vishnu of BTech ECE department, and I am here to explain you about the programming and the software we used for the event of most number of FEMTO satellite launch. We use totally three softwares, namely Arduino IDE, LoRa Communication, and LabVIEW 2020. Arduino IDE, Integrated Development Environment. Arduino is a free software available in Google Chromes. Arduino boards are able to read inputs, light on a sensor, a finger on a button, or a Twitter message, and turn it into an output, activating a motor, turning on a LED, publishing something online. And now you can tell your board what to do by sending a set of instructions to the microcontroller on the board. A microcontroller is a compact, integrated circuit designed to govern a specific operation in an embedded system. So next, we see LoRa communication. LoRa is based on chip spectrum modulation, which has a low power characteristics like FSK modulation, but can be used for long range communication. And LoRa can be used to connect sensors, gateways, machines, devices, animals, people, etc. wirelessly to the cloud. Frequency of LoRa communication is 433 MHz and the range is up to 12 kilometers. Finally, LabVIEW 2020. LabVIEW, Laboratory Visual Instrument Engineering Workbench, is a system design platform and development of environment for a virtual programming language from Natural Instruments. The graphical language is named G, not to be confused with G code. We use LabVIEW 2020 to animate our readings, which is shown in the presentation. Okay, now it's time to launch our satellite. So I invite my friend Jagadish to explain the ground station work.
I think I'm audible. Yeah. Thank you, Vishnu. By now, you would have learned what is satellite, its component, and work. Now, we will see real-time ground station work. This is Jagadish, CSE AI department, here to explain you pre and post-launch work. Shall we start? Yeah, sorry for the interruption. Shall we start? First of all, we will see pre-launch work. Quality checking. For the first more main thing
Jagdish,
we have, yeah, ma'am.
uh, you have noise in your background. Please check.
Okay, one second. Now it's okay, ma'am. I think I can start. Yeah. Quality checking. The foremost main thing you have to do is to check the quality of satellites. As femto satellites are made of carbon fiber, you should check for any damage in case. we have to check for broken parts. In case if carbon fiber has broken or of low quality, we should replace it. Next, there are three main checking that we have to do before launch. That is thermal, vibration, and connection part. First of all, thermal test. As satellite moves higher, we have to check up to what temperature the satellite can withstand. According to that, we have to predict and see the distance up to where the satellite has to travel. Next, vibrational test. In this test, we have to check maximum frequency up to which the satellite can withstand. Next page, please. Yeah. Finally, we have to check whether all connections are perfect. We have to do whether we have all three parts like three main board, SD card, battery, and all other components. They will give you a list. And finally, we have to verify and certify this particular satellite is ready for launch. There are these are the most important things that we should do in quality. Not only here, even in NASA or ISRO, they follow the same. It's a standard process. Next slide, please. Weather report. Now our satellite is almost ready to launch. But before that, we have to check weather as it is unpredictable. We predicted weather for past 7 days, where in that we have to check for wind, humidity, precipitation, as this factor may shatter our launch. To fix the launch time, first of all, we should predict the wind. According to our prediction, we should fix time for launch. As you can see, we recorded all the weather reports and filled it. Ground station should be maintained properly. Like it should have weather reports, quality check reports. You can see we have filled everything in our ground station. Next slide, please. We'll move to test launch 1. Everything was set. Weather was predicted. Now it's time for test launch. There are totally 2 test launches. Now I'll say about first test launch. On our first test launch, there was a bright sunshine and wind was under our control. According to the wind speed, we filled helium gases in the balloon and attached the payload. To be frank, the first test launch was failure. At the time of test launch, our prediction went wrong. We could not control the payload. The payload fell down. We lost the camera and the GPS. There, this was our fault in our first launch. Yeah, mistakes happen. Nobody is perfect. Next page, please. After the 2 test launches, we have recorded the result and we have filed it. Same day, in evening, we predicted the wind correctly. Payload weight was perfect. Rope was tied correctly. Finally, the day was ended with good result. Next slide, please. Now, I will show you the exclusive show, the first test launch video, which we haven't shared anywhere. Here we go, the first test launch video. Thank you. Here we go for second test launch. A cautious time for us, as this time helium balloon is used for the final launch. As the site for launch is Rameswaram, we need to be very careful with helium gas. If we add limited amount of gas, and that too in Rameswaram, we will not get any helium gases. We did second test launch with accurate wind perfect prediction. We did no mistake. The payload weight, rope maintaining was perfect. This time the second test launch was perfect, and we won. The launch is successful. Next page, please. We will see the second test launch video also. Yeah, test launch video, please. The operator, can you please post the second test launch video? Sorry for it. We'll continue. Software integration. Our main aim of launch is to get some useful information. So we thought of checking the signals by using LoRa communication. We tried to transmit signal and receive the data performing by the satellite. Hopefully, we received the exact data and the software was running perfectly. Yeah, next slide, please. Yeah, soldering. Everything's done and we are ready for launch. But our final process is soldering. We integrated all wires and connected with the battery inside the box and attached the camera with GPS. Our launch was on February 7th. We started soldering work on Feb 6th evening. We have soldered 100 satellites. It is not a quite easy job. The particular night we spent full for soldering. I think by 4:30 a.m. we completed our work and by 6 we should be in launch pad. Next slide please. Yeah, launch day. This is an historic event. As we predicted before, again we should predict weather as the wind is unpredictable. Now we have to predict where the satellite will launch. After that, data is collected and where it will reach the land. So we should predict where it will fall by launching site, longitude, latitude, launch date, time, ascent rate, and descent rate. We can predict where it will fall. I think the prediction was near Navaradapuram. But to give you the exact information, here comes our friend Venkat Sayadav from ISDF department.
Yeah, I think I'm audible now. So as previously Jagdish shared what we did actually in the ground station during the launch pad. So what happened next during the launch? It was a great day when we launched the satellites over 2 balloons, helium balloons. So we saw the result was very fantabulous. Actually, the launch day before the weather report was so good enough. We thought the weather would be perfect at the 10:30, but no one can predict the weather at a certain time. At that time, the weather was too high. We could not able to predict what's happening around us, but Mother Nature helped us with every instant. We could able to see the balloons flying over 27 kilometers. It was the final altitude of the balloon, which was required during the readings. We retrieved all the data, but it was actually settled at Kovilpatti, Kolamayur village at final. We retrieved all those data from the satellites after a few weeks. So it was launched on February 7th, but we could able to retrieve all those satellites by March 1st. It was so hard for us to retrieve all those data from the satellites. Think of 100 satellites we are going to retrieve in a single day. It's not possible, right? Yeah, we took almost 2.5 weeks to retrieve all this data and to make it as a compile and to compare with the previous reading which we got. We have successfully launched and we got all those things in our hand. We received all this data from the every satellites which we get. It was almost 38 satellites with the sensors and few satellites with the fibers and few satellites with the seed germination. All the three things have came out successfully and we are here with the record. Thank you guys for giving this opportunity for first year team.
Thank you all. Thank you, my dear students. And we are immensely happy to see our little champs as speakers. And you people have brought a feel of joy and happiness in the minds of all your teachers. On behalf of entire first year students and staff, we congratulate and appreciate the entire team. And from now onwards, we could say, எங்க first year பசங்க நினைச்சா கடுகும் மழையாகும் மழையும் கடுகாகும். And with that, we are moving on to question answer session, for which I would like to call Venkat, Jonathan, Jagdish, and Tarun. Yeah. Yeah, as you say about FEMTO satellites and its launching pad and its activities, here are some few questions that you need to answer. Coming to the power supply, could you please explain about the power supply for this CubeSats and its efficiency?
Yeah,
Like a
I will
duration,
take this
duration
part.
of yeah.
Yeah, ma'am. So the power supply for the entire for a single satellite, it was 5.5 volt. So we are managed in such a way that I've constructed myself a particular structure to give a power supply to all the satellites at the single time. It was a great success at the last moment, but we made it.
Yeah, thank you. And is there any specific reason to send a balloon in a high altitude, send the satellites in a high altitude balloon, but not in a parachute? And could you please elaborate on scientific balloons?
Ma'am, I will take this.
Yeah.
So the reason we have sent in a balloon, it is don't want it to be gone outside the suborbital. We want it to be inside the suborbital. So we have launched in a balloon so that it will be revolving in under the suborbital because of the gravity. It will be retrieving all the atmospheric data. We need the scientific readings of the atmospheric gases. So where the gases will be present inside the suborbital. So we send all the satellites for collecting only the gases which are present among us. So there is no need of launching the satellites outside the suborbital when the need is inside the Earth.
I think it is answer, ma'am. The main reason to
please.
involve students. The main reason to involve students with balloon. We launch in rocket now will not involve many students, ma'am. So they decided to launch with balloon. So more students can involve in it. The main reason is students.
It is cost efficient, ma'am. We can't able to send a satellite launch vehicle for the learning purpose, so we are used in the balloon.
Thank you for all your answers. And you people have talked about weather conditions, right? Weather conditions to be favorable to us, right? And could you say the optimum weather conditions that could enable the launch?
Actually, ma'am,
Yeah.
I'll take this. Actually, we have been taking weather reports since the day of launch. Before the day of launch, till 7 days, we have been taking the weather reports. Everything was perfect, the wind condition, everything was in perfect. But on the day of launch, the wind report was quite higher than usual. Like we have been expecting that we could not be even to launch, but the wind report did make some damage, but it was bearable. So we had made a launch. Yes, ma'am. That's it. The weather report was good. Actually, we expected it much more, but it was quite bearable.
Yeah, as you say, weather report, that stands for humidity and the wind speed, right?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes,
I
ma'am.
will say that part.
Thank you. Yeah,
It consists of wind direction, wind speed, how was the humidity, and all the how will be the wind at the night and the morning. It was noted for past 7 days. At the last moment also, it was noted from the every 5 minutes, every instant, so that the launch could be perfect enough.
Yeah, one particular person allotted for weather checking. You should be checking weather for every 2 hours.
Yeah. And here, is there any specific reason to opt for February 7th?
Yeah, I'll take this. No, not Feb 7. I'll say interesting one. We selected Rameswaram for one thing. It's best place for launch. No disturbance. And main reason is Abdul Kalam residency in Rameswaram. Feb 7 is we have to get permission right now. We have to get permission from DRDO and other airways, seaways. So we got on Feb 7. That's the main reason, not any other reason.
Yeah, I thought like the weather conditions were favorable to for launching on that date.
No, not at all. It was raining before 2 days.
Yeah, and if you take a history, the world leaders of the history like Napoleon, Benjamin Franklin, and Nelson Mandela, they all sacrificed their sleep to give them more time to work. So I think you people also have such experience in the launch pad. And here is a question from Bhargavi. How did you survive in launch station, and how was your overall experience in that?
Yeah, we were under national duty, so sleep did not
Yeah.
disturb us more.
Yeah. Now, when I take the history, I could read like those leaders, they slept only for 1 hour, 2 hours. And here are a little champs who hardly take only
Yeah.
less than 1 hour of sleep, right?
Yes,
Yeah.
ma'am.
Yeah. If
Yeah,
you want
but
to,
During the
maintain the
last
so
weight
day,
loss on the first
ma'am,
day, I
during the
think.
last day, we didn't had a single bit of sleep itself, not even a single minute. So we are working on the soldering work, which is the main part to work functioning of the satellite. So at the last day, we have to give power supply to the whole satellite system in a efficient manner. So we started work by evening 5 after completing our work. So next day morning 4:30 we have completed. By 5 o'clock we are there in the launch pad, and after 6 we have been working on it. So that is when the talk comes to sleep, definitely not a bit, because we are on the duty mission when we need to complete our mission successfully on the day. So when it comes to sleep, no sleep without work.
It was a lot
yeah.
of pressure, but we have to do it anyway. It was a new experience kind of thing. We have learned a lot of things like socializing with new people and teammates who have worked super hard for each part, and it was kind of fun. But same time, we learned some time management kind of stuff.
Yeah, really, even what Venkat says was really true, and I have seen those students, those 3 students who were staying over there. There was no food, what to say, no sleep, but only work is going on. Right. Thank you. And here is another question: how much time does it took approximately for integrating sensors to the board and soldering? How much time does it took during the mission?
Actually, I'll take this question, ma'am. For including the PCB, like it took approximately 4 hours. For each board, it took 4 hours. But overall soldering and completion of single satellite takes around 48 hours. That means 2 days. For one single satellite takes 2 days. And for integrating sensors, it will not be like so much, just 45 minutes. That's it, ma'am.
Yeah. And we'll wind up with the last question. Describe the launching day.
Yeah, I'll take this question, ma'am.
Yeah.
Yeah, contemplation, imagination, and excitement together build the expectation of heightened feeling of action. However, when the actual moment arrives, the sense of satisfaction subdues the excitement and fills with extraordinary happiness. I believe that this is the cumulative happiness experienced during the journey that matters, and witnessing ultimate feeling of achievements during brings peace within. That was so colorful. The launch pad was colorful, flags are flying, and we can hear Vande Madaram. I think our college missed that one. I hope our college is planning for a launch. If it happens, we too will have a great launch pad in our college. You will experience it, we hope.
Yeah, true. So hoping for that fine day. Thank you. Thank
Yes,
you
ma'am.
all.
The last day was very much interesting. When we plant a tree, when we see the fruit in that, we'll be seeing that excitement in our face, the happiness moment, the happy moment. Likewise, the day and night work on the mission, at last it shows the reading. And during that last moment was a very much blissful day for us, blessed by everyone elders who are working on that mission. It was a very interesting and very experienced mission. We have our first working mission was very much interesting for undergoing many experiences in the hardened times.
It was happy
Yeah.
moment with extraordinary persons. We are standing in launch pad. The special guest we are standing in launch pad. MGR students. It's a great credit for us.
Yeah, even I was eyewitness for that day. I could see the great persons, along with the great persons, our NGR students were standing over there with a walkie-talkie in the hand and communicating with each and every other co-teammates each and every time. It was very nice feeling, and that time when it was launched, you people start embracing each other. That was a nice feel of accomplishment. Thank you so much. Thank you so much. And
For
now,
a last word, I will conclude this question answer session, ma'am.
yeah, yes.
Yeah, we have made this meeting only not to the only hope for us to educate everyone to share our knowledge. There is the greatest asset for me is to share the knowledge which I have gained. During this mission, I've gained a lot of knowledge, so I don't want to miss it for my friends who was missing it. So I've shared all the knowledge which we are there. All our friends have shared all the things which we know. So I hope this will be helpful for your future for the projects which we do. Thank you guys for giving this opportunity for us.
Yeah, even I too agree with Venkat. When we learn, we have to teach, and when we get, we have to give. It's all about giving value to others, and I think that could be the motto of you people, your team. Thank you so much. And coming to the chat box, it's brimming with appreciations, and there is a message from your friends stating that you are great motivation for all of us. Thank you all for making the session so wonderful. Now, the grateful hands and the mindful hearts are roped in to express vote of thanks. Can we have Jonathan and Dice, please?
Yes, ma'am. Am I audible, ma'am?
Yeah, please.
Okay. So now I'll start with a word of thanks. I'd like to thank our President, Engineering ACS Arun Kumar, who has given sponsorship for students and also for the transportation of students for Rameshwaram. I also like to extend my gratitude to the higher officials who supported us from our university. I'd like to thank to Dean EPA L. Ramesh sir who traveled with us for the entire work and also supported and encouraged us with his motivating speeches. And also thank Dean Ma'am Dr. N.S. Shubhashri, who exclusively selected first years for this mission. It was pretty new experience for us, and also we have been given on duty for 7 days of trip to Rameshwaram. Yet we didn't bore apart from this academic studies. We managed to get a grip on it once we came back. I'd like to thank our team coordinators, Miss Lata ma'am and also Kavita ma'am, who has taken care of us on this entire trip to Rameshwaram, starting on the travel, the food we ate, until we safely reached home. We are in great hands during this entire mission. I'll also thank to our seniors who supported us and guided us in this entire mission. And last, we'd like to thank to ourselves for being cooperative and also self-dedicated towards this mission. And also special thanks to our team who went to Rameshwaram a week before and put a lot of effort and hard work into it. A very special thanks to APJ Abdul Kalam International Foundation and also to Dr. Anand Megalingam sir, who is the CEO of Space Zone India, who were the main pillars of this mission. And finally, a special thanks to one and all present during this entire session, listening to our enthusiastic words. Herewith, I'll enclose the word of thanks session with some few words in Tamil. எங்களை வளர்த்து விட்ட அனைத்து நல்லுள்ளங்களுக்கும் என் நன்றிகளை தெரிவித்துக் கொள்கிறேன். நன்றி.
Thank you, Jonathan. That was a nice word. Myself, being a coordinator for first year team, I joined with our students in thanking our benevolent patron of our university, the engineer ACS Arun Kumar sir. And we also thank Ramesh sir and Dean ma'am for having given an wonderful opportunity to work with Abdul Kalam Foundation. And we people call Abdul Kalam sir as people's president because of his easiest way to approachable. He's so approachable, and not only sir is so simple, his entire family members are so simple and very easy to access. That was we learned on the launch day, and I'm greatly indebted to all my dear students, the active students of the mission, Vishnu, Jagdish, Venkat, Jonathan, Tarun, and Sherin. I also extend my thanks to the students Bhargavi, Tarun, Kumar, Nandini, and Jabir, who are the pillars of support for the entire mission. You guys are in a big picture of MGR. And we could view your sincerity, discipline, dedication, and your intelligence, emotional intelligence, as a reflection of entire first year students. Thank you all. And to all my dear students, let's not celebrate the missed opportunities alone. Many such ocean of opportunities and opportune moments are awaiting at our university. Do avail and achieve. Thank you all.